Good morning, students. Welcome to science class. Last meeting, we have talked about several subchapter. That is subchapter 9.1, 9.2, and 9.3. Based on that chapter, students, we have gotten several summaries. One, force act on the object to push, pull, stretch, and turns. 2. Forces happen when two objects interact with each other. 3. A force arrow shows the direction of a force. 4. Forces are measured in newtons or capital N. 5. Force are measured using force meter. 6. Mass is the amount of the matter in the object measured in kilograms. 7. Weight is the force of the gravity on objects measured in Newton or capital N. There are summary that we got students for the last meeting. Okay. Today we are going to talk about another subchapter. There are subchapter 9.4, 9.5, 9.6. Okay, students, please open your book, page 136. Subchapter 9.4, Frictions. Friction force is important force in our life. You should be able to feel the force of the friction, students. For example, look at this picture. There is a girl rub her hand together. Okay. Students, rub your hand together hard, then wait until several times. You feel that hand will start to get warm, students. The warmth of your hand, students, is observed as the heating effect of the frictions. Means when you rub your hand, there is friction between the hand, students. Okay, friction is a force that can appear when two objects are in contact each other, students. In this case, your two hands is contact each other or touching each other, students. Another example, look at this one. There is a boy and then this one is heavy box. The boy want to make the box move. So that's why the boy give the four students. Okay. If the force of the boy is not enough to make this move, means that the friction force is bigger than the force. The opposite one, students, if the boy give a bigger force and then the objects move, mean that the force is bigger than the frictions. Okay, students, if you push hard enough, the box will move. Your pushing force is greater than the force of friction. Okay, one more time, students. If you want to make the objects move, of course you have to give force is bigger than the friction force in the box or the objects. Okay, students. How about the direction of the friction, students? Okay, look at this picture. Okay, look at this picture. Students, we say that the friction acts to oppose motions. Okay, one more time, students. The friction acts to oppose the motions. Okay, to draw the force arrow to represent friction, you must ask yourself, which way is an object move or trying to move? You have to know the direction of the motions, or you have to know the possibility, the direction of the motions. Okay, students, for the example, this one. The heavy weight in the picture is trying to slide down the slope, right? And then this tells us that the direction act up the slope, students. Okay, the direction of the friction is up. Okay, and then without friction, the box will slide down slope directly. Then, how to investigating friction, students? You can use a force meter to measure the force of the frictions. How? Place a wooden block like this on the bench and then pull it with the force meter like this, students. When the block just start to move, the force meter will show you the value of the force. Okay, student? And also, you can investigate the different factor that affect the size of the force of the friction, students. Okay, there is three kind of the factor the effect of the size of the force of the friction, students, or we can say uh, how to decrease or increase the friction force, students. Okay, one, you have to add weight on the top of the block to make it heavier. Okay, it means that heavier objects will have bigger friction force. Okay, and then the other one, turn the block so that the different phase in the contact in the bands, like this, students, this change the area of the contacts. Means that the bigger area, the force will be higher or bigger. Okay, and then the last one, use a material such as a paper or cling films to cover the surface, making it rougher or smoother. If the surface is rougher, it means that the force is bigger. Friction force is bigger. If the surface is smoother, students, means there is no friction actually. Okay, or the friction force is smaller. Okay, this one is the factor to increase or decrease friction's force. Okay, from this subchapter, students, we can take some kind of summary. What is that? One, friction is a force that acts when two surfaces are in contact with each other, students. The second one, friction act to oppose motions. Mean that the direction of the friction force is opposite with the direction of the motions. Okay. Let's discuss another subchapter. There is 9.5. Students, please open your book, page 138. Subchapter 9.5, Air resistance. If you drop something, it falls to the ground. Why? That is because of the object has weight. What is weight? We have learned about this one, students. Weight is the pull of the earth gravity that makes the objects fall. Look at this picture, students. There is parachutists falling, right? And then several minutes they will reach the earth of the surface. Okay, but the parachutists will not be travel very fast when they hit the ground. Why, students? Because they are falling through the air. It means that there is another force acting on the parachute. What is that, students? The extra force in the force in air resistance. Okay, the the force of the air resistance slow them down to a safe speed. Okay, not directly hit the ground, but they will go down or fall down with the safe speed. Okay, students. How can the parachute can fall down with the safe speed, students? Of course, there is another concept. We call that one is balance forces. As we know that the parachute is fall, air resistance pushes upward on the inside of the parachute like this, students. We can represent this force using a force arrow pointing upward. Okay. In this picture, students, there are two forces acting on the parachute. This right? They are equal in the size but point in opposite directions. Mean that the direction of air resistance is opposite with the direction of the weight. Okay, students. Uh, Both of the force cancel each other out, students. The parachute will fall at the same speed. Okay, because uh, the net of the force is zero. When the forces cancel each other out like this, we say that the force is balanced. How about unbalanced force? Unbalanced force means there is two force or more than one force, but the magnitude is difference between upward and downward, between left, between left or rightward. Okay, student. As long as the total or the net of the force equals zero, we can say that one is balanced. If the net of the force is not zero, it means that one is unbalanced. Next, students, moving through air. It is easy to wave your hand through the air compared to another substance. Why? Because air is very thin substance, so we can move easily through it. That's why a parachute must have such a big area. If the parachute have a small area, it will be useless, students, because the parachutists will go down so fast, and then that one is will be dangerous. Okay, another example, look at this picture, students. There is flying squirrels. If this one want to glide from one tree to another tree, of course, this one will help it to easily jump to another ones. Okay, why? Because there is air resistance push this area. Okay, it's not easily to fall down in the ground. Next, students, air resistance and frictions. What the relationship between air resistance and frictions? Okay, air resistance is like frictions. It tends to slow down anything that is moved. A large area give a lot of air resistance, students. For example, student, a twistle seed will float slowly downward, students. The wind will carry it from the parent plant. Another one, the aircraft in the photograph is designed to move easily through the air. Why? Because a shape like this is described as streamline. Okay, so means that very easy to push up the plane. Okay, so that's why this one is called streamlined. Okay, students, from this subchapter 9.5, we can make summary like this. 1. Air resistance is a force that acts on objects moving through air. Then, streamline shape reduce air resistance. Subchapter 9.1, Pattern of falling. When you drop a ball, like this picture, students. Okay, it is difficult to see exactly what is going on, students. The ball leaves your hand and almost immediately it hits the ground. One way to see the pattern of the falling object is to film it and then slow it down so that you can see in the slow motions. Look at the picture, students. This picture is the pattern of falling ball like this. There are 7 photographs of the falling ball were taken in equal interval time, students. So between one to another one, the interval time is the same things. As the ball fall, the photograph get further apart like this. Okay, between one ball to another ball, there is different distance. Okay, this show that the ball is speeding up. The ball speed up because the force of its weight pull it down. But in this case, air resistance on the ball is very small. Okay, students. Another one, students. Galileo and the Leaning Tower. Galileo was one of the first true scientists. He lived in Italy 400 years ago. He investigated how things fall. Galileo performed a famous experiment, students. He climbed to the top of the Leaning Tower of Pisa. From there, he dropped two iron balls, one much bigger than the other ones. What happened with that ball, student, those ball, students? The most people expected the bigger ball to land first, but they were wrong, students. Galileo predicted they landed at the same times. Why did people have the wrong idea? They were used to see lightweight about the falling slowly. Air resistance slow them down, but very little air resistance act on the iron ball. So, ball of different size fall at the same rate, students. Mean that if you have two objects, different mass, and then at the same times, you release the balls, and then they will reach the ground at the same times also. Okay, student, doesn't matter the big of the objects or doesn't matter the size of the objects. Okay, they will reach the ground at the same times. Remember, that is not. What is not? The air resistance is very small. Okay. From this, students, from this subchapter, we can take a summary like this. Falling objects speed up as it falls, provided there is no air resistance to balance its weight. Okay, students, any questions? Please, if you have a questions, let me know. If you any doubt about the chapter, let me know. Write down the question in Google Class. I will directly answer it for you. Okay, to make everything clear. Students, we have learned about falling object, right? And then this one is your activity that you can do in your house. Okay, you have to record the result and then please submit the result and then through the email. Okay, look at this one, students. Activity 9.6, investigating fallings. Okay, you have to follow this instruction. In this activity, you will measure the time it takes for different objects to fall to the floor. Okay. 1. Find a selection of objects which you can safely drop. For example, marble, shuttlecock, rubber ball, pebble, crumble, sheet of paper, or table tennis balls. Okay, and then use stopwatch to time each falling object. You must start timing when the object is released and stop when it reaches the floor. Try this out and then find the best way to do it. Okay, number three. Before you start your investigation, think about these things, students. All the objects sulfur from the same weight. Why? Then, the greater the heat, the better. Why? Next, put your object in order, starting with the one you think will fall in the shorter times. Okay. Then, number four, draw up a table to show your result. For each object, record the distance it has fallen and the time taken. Okay. To be more sure, your answer, students, time its fall 3 times and find the means. Okay. That means that your table will need 6 columns. Okay. For example, one object like this, you have to take at least 3 times. Okay, with the same height like this. With the same height, you have to calculate 3 times. Okay, now make your measurements. Number 6, study your complete table of the result. Do some the object fall more slowly than others? Okay. And then number 7, try to explain your finding using the ideas about forces, okay, weight and air resistance. It will also help if you think about the result of Galileo experiment that we have learned. Okay. Students, one more time. If you have done do this one and then make a record, then answer the question in this activity. Please send through the email that teacher Widodo given to you. Okay, students, good morning, have a nice day, and God bless you.